Hello, today we are doing Unit 0.6, Review of Trig Functions. Yay for Trig. So the first thing that we're talking about is a radian. A radian is a unit of measure along the arc of unit circle. The unit circle is 2 pi full rotation, and remember 2 pi is the same thing as 360 degrees, telling us that we're going all the way around the circle. If we're wanting to go from degrees into radians, we're multiplying by pi over 180 degrees. If we're going to go from radians to degrees, we're multiplying whatever that is by 180 degrees over pi. So you're just flipping it to end with whatever you want. If you want to end with pi, you have pi on top. If you want to end with degrees, you have degree on top. This next thing that we're looking at here, it's talking about arc length. So for a circle of radius r, a central angle theta subtends an arc length of s given by this formula. So it gives us this formula. So s would be the arc length, r would be our radius, and theta would be our angle. And so this one says, how far does the end of a minute hand travel in 10 minutes if the hand is 12 inches long? So the first thing that we need to think about is, what is our radius? What is the length of the hand? This is the hand of the clock. And so it tells us 12 inches long. What is our theta then? Our theta is how far it's gone. It started up here and it's going 10 minutes, or it starts wherever, but it's going a total of 10 minutes. So how could we figure out how many minutes? Well, let's think about it. How many minutes are in an hour? There's 60 minutes in an hour and we have 10. So we have 10 out of 60 times our 2 pi. We're looking at 1/6 of the full length around is what essentially that's saying. And then finally, our s, we're just using our formula, radius times theta. So we have 12 times, I'm going to simplify 10 over 60 to 1/6, 2 pi. So we get there, and we know that we could multiply the 1/6 times the 2, so we would get 2/6 pi. I could actually cancel this out here, the 6 and the 12, that gives me 2, and I get 4 pi inches. That is how far it travels. All right, next we're going into just some common angles. If you remember your unit circle, this is going to come very naturally to you. If you don't remember your unit circle, you need to remember your unit circle. Your AP test is going to be full of questions where you need to know your unit circle. So I'm just going to draw one out for you really quick, help you think through like the way that I try to remember it. So we know that this is our 0 degrees, our 90 degree angle, our 180 degree angle, and our 270 degree angle. At our point here, it's 1, 0. The way I think about it is you're going right. So that's going to move this x value 1. And then we can split this. And we know we have our 30 degree angle and our 60 degree angle. So 30, 60, 90. At 30, we're at root 3 over 2 and 1/2. And then in between both of those, we have our 45. So we have root 3 over 2, 1/2, and then we have root 2 over 2, root 2 over 2. And then at our 60, we have 1/2 root 3 over 2. So the way you can remember it is 3, 2, 1. We start with root 3, we go to 1, or we go to 2, and then we go to 1. Also, you can remember that like this is going to be shorter. Root 3 over 2 is stretching out further than 1/2 would be. So you can kind of think about it that way. Then we have 0, 1. So let's see what we can fill in already. So we know at our 90 degree angle, we are looking here. Hold up 1 second. These ones are just looking at what our radians are at. So looking at our unit circle, we can also get some of these radians out for us. And all of this circle is just divided into pieces. So this is 0, this is pi over 2, it's half of it. And so what's half of half? A fourth. This is our 1/6, and this is 2/6, which is the same thing as 1/3. So you should be able to divide your circle out that way, and if you need some more help on this, you may need to to ask for some help, but I'm going to go ahead and write them in. So 90 degrees is the same thing as pi over 2. 180 degrees is the same thing as pi. We have 270 is 3 pi over 2 down there. 45, that's our pi over 4. It's our 1/4. And then 135 is this other section here. That's our 3 pi over 4. 225 is 5 pi over 4 because they're each going. See, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. And so these all simplify to 3 pi over, like to reduce there. 315 is 7 pi over 4, right there. And then these are our sixths. 30 degrees is pi over 6, 60 degrees is pi over 3, because that's 2 pi over 6, which it reduces to pi over 3. And then we have 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, and 5 pi over 3, and 11 pi over 6. All of these had bases of 6, but we can just simplify them. Okay, if we have a negative degree, instead of this going to 3/4 over pi, which would be here, we're just going to go the other way. We go backwards to get those negative radians. Okay, sine, just to refresh, sine is opposite over hypotenuse. So katoa, right? So adjacent over hypotenuse for cosine, ka, and then toa, tangent, sine over cosine, which is the same thing as opposite over adjacent. So cosecant is just the inverse of sine. We're saying that's 1 over sine. Secant is 1 over cosine. And you could have your thetas here. And cotangent is 1 over tangent. So opposite of sine is cosecant, opposite of cosine is secant, opposite of tangent is cotangent. They're inverses of each other. Sine of pi over 6. This is where we could go back to this unit circle that we were starting to draw. Remember, it's cosine comma sine. So sine of pi over 6 is going to be 1/2 there. These are values that you have to know. They're going to come up on your AP Calculus test, and they will come up on the non-calculator portion as well. Sine of pi over 3 is √3 over 2. If you can draw your unit circle out, though, you're going to be golden. Any pi over 4s, these are both √2 over 2, right? And then when we do tangent, which is sine over cosine, I'll do an example for you real quick. That's just 1, because they cancel each other out. Cosine of pi over 3 is 1/2. If we do sine over cosine, it comes down to √3, and then √3 over 2. So basically, long story short, guys, know your unit circle, memorize it. If you don't, look it up and try to remember those key values. Sine of 0 is 0. Cosine of 0 is 1. And tangent of 0 is 0. And again, these are just these points here on your unit circle. Sine of pi over 2 is 1. Sine of cosine over, or cosine over 2 is 0. Tangent of pi over 2. Can we do that? Sine over cosine, 1 over 0. We can't. That's undefined. Sine of pi is 0. Cosine of pi is -1. So sine over cosine is just 0. Sine of 3 pi over 2 is -1. Cosine of 3 pi over 2 is 0. So if we do sine over cosine, we get 1 over 0, which is also undefined. Sine of 2 pi is 0. Cosine of 2 pi is 1. So sine over cosine, we get 0. 0 divided by 1 is 0. Okay, so let's look at our graphs of our sine functions. Remember that sine starts at the origin. It gives you something like this. We have an amplitude of 1, which means that it goes up and down a total of 1. In our general sine graph, our amplitude is 1, but it's also our a value. Whatever's in front of that sine of x, that's going to tell you what your amplitude is. This is actually, if we figure out what is sine of -x, it actually gives us negative sine of x. So that tells us that this is actually an odd function. So sine graphs are an odd function. Our period is 2 pi. it starts at 0 and it ends at 2 pi for the function. However, if there was a value in front here, then it would be divided by whatever that value is in front of x. And then any shifts that we would have happen, it would go up or down just depending on what was being added to the outside of the function. It can be written as negative c over b. So cosine is very similar, however, it starts at 1 and it cycles through its period like that. This is actually an even function, guys, because cosine of negative x is actually cosine x. If we plug it in, we get the same thing. Our amplitude is a as well, whatever's out in front. The normal amplitude is 1, and then the period is also 2 pi, but you divide it by whatever's in front, and your shift is going to be the same. Tangent's a little bit more funky. It goes like this, and we have an asymptote, and then we have this. And remember, it would continue. So like this would go up like that, and it keeps going. But the period would end here from 0 to 2 pi. So our period, 0 to pi is pi over b. Our amplitude does not exist because it's going on forever there. Tangent of negative x is negative tangent x, so this one is also odd, just like sine. And then our shift would also be negative c over b. Okay, these are important to commit to memory. Your sum and difference formulas, sine of alpha plus or minus beta is, and this could be any values that you're plugging in. Sine alpha, cosine beta, plus or minus cosine alpha, sine beta. Cosine alpha plus or minus beta is cosine alpha, cosine beta, minus sine alpha, sine beta. And then tangent of alpha plus or minus beta is tangent alpha plus or minus tangent beta. And you're following whatever the sign was. So if this was plus, you would follow the top there. If this was minus, you would follow the bottom there. We get 1 minus tangent alpha, tangent beta. And so we also have our double angle formulas. Sine of 2 pi is 2 sine theta cosine theta, which helps a lot with breaking things out. Cosine of 2 theta is cosine squared theta minus, that was a horrible minus, sorry, sine squared theta, which we could break down even further to 2 cosine squared minus 1, because sine squared, remember, this one maybe we need to write off to the side, sine squared plus cosine squared equals 1. So cosine squared is the same thing, or sine squared is the same thing as 1 minus cosine squared theta. So this one would also equal 2 cosine squared theta minus 1, as well as 1 minus 2 sine squared theta, if you used this identity to plug in to rearrange the formula. Tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. There we go. All right, and now we're entering into our inverse trig functions. So inverse means that we're flipping it, remember? And so anytime that we're flipping any of these functions, it's meaning that it's giving us the value and we need to go back and figure out like what it is for sine. So sine inverse of this, what it's actually saying is it's saying that sine of theta equals this. What's theta? It's a backwards question. We're flipping x and y. And so we would just need to look back to our unit circle. Where would this equal negative root 2 over 2? And it would actually be at negative pi over 4. Or like you could have written it as your last quadrant. Let me pull up our unit circle so you can see it. Because it would be here. So what point would we be at on this circle? This would be 6 over, or sorry, it would be 4 over 4, 5 over 4, 6 over 4, which is 3 pi over 2, which is also negative pi over 4. So negative pi over 4 or 3 pi over 2. Either of those would be what that value actually equals. Okay, last one. Solve this one. This one we're actually going to need our calculator for to be able to graph it. we are looking at cosine x. We're trying to figure out, if we're ever trying to find a solution, we can always graph the intersect to see where they cross each other. So we have 0.2x. Let's see where they cross. Got our super awesome cosine function. Groovy. And then now we have our 0.2 x line, and we can see where it intersects. Second, calculate, intersect. I'm going to graph my first and my second. And it tells us our intersect here is at 1.306. And we got to see if there's any other intersects. Do you see how it crosses there? But I should have a couple more. So let's see where else. Over here, I see another intersect. And we have it at negative 1.977. And remember, we're rounding to 3 decimal places. And our last intersect is over here. Negative 3.837. Those would all be solutions to my graph here, where those two are meeting. Thanks, guys.